In the traffic engineering profession, we're constantly looking for ways to reduce or eliminate left turns. They are a consistent source of crashes and delays. So anything that can be done typically to reduce or eliminate left turns typically is going to result in a safety and an operational benefit. A lot of this content is from the Federal Highway Administration various informational guides, and this is just a sampling of some of the intersection types that are used to reduce or eliminate left turns. It's not exhaustive, but just kind of introducing us to some of these intersection types that can reduce or eliminate those left turns. And we need to think about it in their context. So the Federal Highway Administration has this great image showing as traffic volumes increase, you may exceed the capacity of typical signalized intersections or large signalized intersections, but you're not quite at the level of a grade separation. And this is where those alternative intersections, and typically those involve some way of adjusting those left turns. So starting with grade separations, that's that kind of next level you would go to. So obviously this works well to avoid those left turns. So if you're thinking about you're on this facility, in these examples, interstates, freeway access control facilities, you do not allow a direct left turn to cross that other direction. So to do that, we grade separate them, you exit, and then you make your left turn over or under that main line. Very common approach for solving the left turn issue is using roundabouts. So the roundabouts, and this is showing compared to a typical four-leg intersection, you eliminate all of those, in particular, very dangerous crossing conflicts, and you simplify that intersection, removing those left turns. Everybody turns right around the roundabout and then exits at the appropriate leg. So roundabouts are a great solution for removing those left turning movements. So this is the median U-turn. The idea here is there's no left turns at the intersection. So if you're on the main line, what you'll do if you wanted to turn left at this intersection, you can't do that. You need to go through the intersection, do the U-turn, and then come back to the intersection and make that right turn. So that's what the left turn from the main line to the side street looks like. The left turn from the side street to the main line ends up looking like a right turn. Come and do the U-turn and then go through. So that's the left turn from the side street to the main line. And you can use bulb outs. This is shown in this other portion of the image to allow larger trucks to make that turning movement, larger turning radii. And you can also do it where it's a two-stage merge, so the vehicle can cross the lanes of traffic, then wait here for an appropriate gap, and then continue on with their turn. Here's an example of some marketing material. This is from Tucson, Arizona. This median U-turn called the Express Left there, and just explaining to drivers how to do this. You need to go through, do the U-turn, and then make the right turn in this simple 1, 2, 3 step process. So this is an RCI or Superstreet or RCUT or J-turn, different states, federal government refer to these in different ways. The RCI stands for Reduced Conflict Intersection. RCUT stands for Restricted Crossing U-turn. Somewhat has a similar look of a median U-turn, and then we'll talk about the differences here. Can be done at a corridor level, which is popular, or also at a single intersection. Here's an example of a signalized RCI. And so we have signals at the main intersection, 2 signals, and signals also at the U-turn. These don't have to be signalized, and I'll show a couple of variations of this. It can be useful in certain circumstances. The nice thing about an RCI is you can get perfect progression because essentially each direction acts like a one-way street. So from a signalizing perspective, you can get a lot of efficiency and benefits there. From the side street, you need to do the same maneuver as a median U-turn, turn right, do the U-turn, and then go through. You can, though, make a direct left from the main line, but there's no direct through on the side street. So these are some of the differences and similarities between the median U-turn and the RCI. Here's an example of a stop controlled RCI. So similar in look and feel. This is more common typically in a rural area where you don't necessarily have quite as high of traffic volumes, and so maybe the stop signs will work from an operational perspective. And you can also use yield signs, again, depending on the specific operations of the location. Now we have the displaced left turn or the continuous flow intersection, and similar to most of these intersections, there are multiple names for them. A lot of states use their own terms. Sometimes the federal government uses a different term. So it's important to know what we're working with when we have these. And the idea here, again, with the left turns is that we have a crossover point before you reach that main intersection. So essentially the vehicles that want to turn left, they go ahead and cross over the opposing direction before they reach the intersection, and then they'll actually make that left turn while they're not opposing that full through movement in the opposing direction. So that's the concept here with the displaced left turn with continuous flow CFI intersection. And here's an example of an actual design. So here's our crossover point. So if you're approaching this intersection to turn left, you're going to cross over here, and then you'll actually make your left turn at this location again, so you're not opposing these main through movements in the opposite direction. The quadrant roadway intersection is becoming more and more popular. The idea is that you utilize a quadrant roadway to help you handle your left turns. And so you could turn, in this example, you could turn left before the main intersection and then left on that arterial. In order to go left from the opposite direction, you'd go through the intersection, make multiple right turns, and then go through. In this example, similar over here on the arterial, you turn right and then left on this cross street, then go through. Similarly here, you're going to go through the intersection, left turn, and then make your right to complete that left turning maneuver. So depending on the exact movement, some extra distance traveled, but this is the quadrant roadway intersection. Here's another one looking at connector roads and multiple quadrants. So now we have these quadrant roadways in multiple quadrants of this design. The jug handle is another one very, very common to see in New Jersey. And the idea here is to move this left turn to the right. So we're going to push it further this way to then make the left turn known again as a jug handle intersection. And here's just an image of an actual jug handle, so turning right, then to make this left turn to go through the intersection. So now we're going to take a look at some designs from NCDOT. This is Kings Highway at Van Buren Road, and we're going to look at some different alternatives that incorporate some of these designs that give us some options for the left turns. So you're zooming out a little bit. We've got certainly have some restrictions in place with a healthcare center, shopping centers, other things around this corridor in each of the quadrants. So things to think about as we're thinking about different designs that could be implemented here. So to start with, we have an RCI. So zooming in here at this main intersection, we can see that the left turns are restricted. From the side street, you need to turn right and then do a U-turn to go through. From the main line, you can take that direct left turn onto the side street, but no through movements on that side street. So that's one of the options. The next one that we have is a CFI, it's a continuous flow intersection. And we'll notice the key part of this is that crossover point before the main intersection. So if you're turning left, you're going to make this crossover here, and then you'll turn left here for the CFI. Our next one is a connector or U-turn. And so this is incorporating some of those same components of a quadrant roadway. So looking at this as a network, where can some of these additional turns be made to make those connections? And finally, one of the other alternatives considered was a modified compressed diamond. So this is using those ramps, so exits and entrances, to remove those left turns from that main line and grade separate this intersection. So these are some of the options that can be used to reduce or eliminate the left turns, and ultimately it's part of those solutions when you've reached the end of capacity from a traditional signalized or even unsignalized intersection, and you need some other alternatives to either operate traffic safely or efficiently. Hopefully both of those improve their safety and operational performance.